Hey guys, welcome to the next lesson on potential energy. So in this lesson, our objectives are to gain an understanding of what potential energy is and to be able to calculate gravitational potential energy. So potential energy is the ability to do work. So if an object is held up in the sky, for example, this brick, it has the potential to fall. We define it as having potential energy because it can do work where it can fall, move into kinetic energy, and move an object, or it can push a turbine, which will then generate electricity. But it's the potential to do work. This on the ground can no longer fall. Therefore, it does not have any potential energy because it cannot do any work. Another example of potential energy is a car at the top of a hill. It can move. Once it's off the top of the hill, it will move into kinetic energy. Therefore, it has the ability to do work. There are three types of potential energy. The main type we're going to be dealing in today's lesson is gravitational potential energy. There's also chemical potential energy, which is the energy stored in chemical bonds. And there's elastic potential energy, which is stored in stretched elastic objects. For example, such as a bow and arrow or an elastic band stretched. Whereas chemical energy is the energy in bonds. So you burn a block of wood, that's chemical energy coming out. Gravitational potential energy is the energy of objects stored up high. So gravitational potential energy is the energy of an object possessing because of its position. So the higher the object is, the greater its gravitational potential energy will be. In these three diagrams here, we have potential energy or gravitational potential energy shown in blue, and blue here and blue here. We can see that at the highest point, so the highest point of the track, the skateboarder has the highest gravitational potential energy. As they begin to move down the track, you can see they have less gravitational potential energy, shown in blue. So it's a medium amount here, a high amount there. And when they get to the bottom of the track, they can no longer do any more work. They can no longer move back up with their gravitational potential energy because they have none. However, because of their kinetic energy, they will be thrusted back up. The point of this is the higher you are, the more gravitational potential energy you'll have. The lower you are, the less you'll have because you no longer have the ability for gravity to act against you to fall. Gravitational potential energy, as I already mentioned, is an energy an object has because of its position, and it's calculated by the formula gravitational potential energy equals its mass in kilograms again, just like it was for kinetic energy, times gravity, which is in meters per second, and on Earth we call that 10 meters per second. Different planets is different. And then we have the height in meters. So an example of this, a 80 kilo skateboarder is moving up and down a half pipe on Earth. And as I said, the gravity is 10 meters per second. At their highest point, they have an elevation above ground, 3.5 meters. So plus 3.5 meters above the ground is the highest point they travel in this half pipe. You're asked to calculate the gravitational potential energy of this skateboarder. So what you do is simply you put in the values based on what we were told in the last slide's information. GPE, gravitational potential energy, equals its mass in kilos times gravity, 10 meters per second on Earth, times height. So we've got mass is 80 kilos times gravity, 10 meters per second, times height, 3.5. You put those into the equation and you'll get 2,800 joules, a capital J again. Second example, gravitational potential energy. How much gravitational potential energy is there when you lift a 200 gram box on top of a 2.25 meter shelf on Earth where gravity is 10 meters per second? So we know that it's mass in kilos times gravity in meters per second times height. Now over here we've got a 200 gram box, which would be equal to 200 divided by 1,000, because 1,000 grams equals a kilo. So a 200 gram box would equal 0.2 kilograms. So that's why 0.2 kilograms is written there, times by 10 meters per second, times by 2.25 meters of height. Therefore, you have 2 times 2.25, so it's 4.5 joules of energy for this box to be lifted up to this shelf. This is a summary of this lesson. Potential energy exists in 3 types, which you'll need to know: gravitational potential energy, chemical potential energy, and elastic. Gravitational potential energy changes with its height. So as you get higher, it becomes higher. As you get lower, it becomes lower. And it's calculated by the formula mass in kilograms times height in meters times gravity in meters per second. And these are the terms you need to know. These are the questions I'd like you to answer before the next lesson. Making sure that this question here, using the picture below, describe why gravitational potential energy would be the highest, and use the equation. You need to use the equation in your answer to explain why whichever point you choose would be the higher gravitational potential energy. Thanks for watching.